Hello, everybody, and welcome to the Open Mainframe Project monthly webinar. Today we have the October 2020 Zowe Quarterly Update. We will be recording this, so if you miss any part of it, you can see it on the recording. If you have any questions during the session, please feel free to use the Q&A box. We'll try and answer them as we go along. And finally, we'll be asking a bunch of polling questions. So we will have limited time, so we probably won't get to the answers. We will be following up tomorrow with answers from our polling questions. And with that, I'm going to hand it over to Rose. Welcome, Rose.
Hey, thanks, Chris. Can you hear me okay?
I can hear you perfect.
Okay, super. Thank you. So good day, everyone, and welcome to the inaugural Zowe Quarterly Webinar. We plan to host these webinars once per calendar quarter, and this one will obviously serve as our Q4 2020 webinar. I'm Rose Sekach, Zowe Onboarding Squad Lead, and I will be kicking us off and wrapping it up. So we've got a full agenda. We've got just under 60 minutes, and here's our plan. We'll review the intent of these quarterly meetings. We'll provide a brief update on what's happening with Zowe. Then we'll dig into this quarter's focus topic, which happens to be ZSS. We'll follow that up with a deeper dive on a specific Zowe squad, and this month we'll be featuring the Zowe CLI squad. Before we end, we'll list out some important events with dates and share links with you where you can continue to stay in touch with the Zowe community. Time permitting, we'll open it up for Q&A, but please, as we go, do type in any questions you may have in the Q&A area, and we will work to address them and respond to them as we go. And finally, as Chris said, we have a few poll questions, and we'll present them after the focus topics and the focus squad portion of the webinar. And we'll, as she mentioned, we'll be sending out those results with the webinar recording. So on to the series overview. So our intent for this webinar series is to ensure that the Zowe community offers a forum for open exchange of information, ideas, and affords both the members of the community and those beyond the community insights into what's happening with this project. Our plan is to host these webinars 4 times per year, once per quarter, as I mentioned. What we'll do is we'll feature a technical topic and at least one Zowe squad. We'll also use the forum to help bring awareness around upcoming and in some cases, some prior events that have happened. In this case, Bruce is going to talk about the PI planning that we just completed. And then finally, we're hoping to leverage it as a means to collect feedback from our wider audience and anyone who's interested in all things Zowe. So with that, I'm going to turn it over to Bruce to give the Zowe update.
Thanks, Rose. First of all, a shout out to Rose for pulling this together. We do think communication to the community, two-way communication is critical for the success of this project, and Rose has been a great help with this. So this is Bruce Armstrong. I'm a member of what we call the Zowe Leadership Committee. It's a group of 6 of us that try to keep up with what the various squads are doing. When we refer to squads, these are the development teams that vary in number, but let's say, you know, they're between 10 and 12 folks specializing in a given component of Zowe. As Rose said, we do what we call program increment planning once a quarter, and this is when all the developers on the project get together. The different teams lay out what their agendas are for the upcoming quarter. We work on cross-team communication, and we get, I'll say, consensus on the things that we're working on is what makes sense for the community. This process is open to anybody. We want to stress that, you know, whether it's a meeting at the Zowe leadership level, an individual squad, or these planning sessions that we do, they're open for anyone and everyone to comment and get involved. Rose, if you go to the next slide. So real quick, when we talk about these squads, as I say, we break it up on technology, and in some cases, I'll say by discipline, right? The first 4 there should be obvious if you're familiar with Zowe and the technology that we build and ship. The systems team is the team that we've given that name. It's terminology used in agile development processes for the team that does the build, the test aspect. We've also expanded that team to be involved in packaging as well. Onboarding is just that. Rose is a part of that. Onboarding is just jargon that we use to help people learn about this technology, whether you want to contribute to the community or consume this technology in your enterprise, in your product, whatever. They're a bridge between the open community and those of you wanting to use the technology. And then the documentation squad, and it's not just limited to documentation. This team also helps a lot on the website and different aspects of describing the Zowe content. As I say, the community gathers on a quarterly basis. What I did is provide a link to a recording of, I'll say, one of the cross squad meetings. So this is where you'll hear from the squads what their priorities are for the upcoming development. Rose, if you go to the next slide. For the sake of time, I am not going to go through every one of these bullets. We want to turn it over to Joe Devlin and Mike Bauer as soon as possible. But I'll just hit a couple of highlights just for folks' awareness, things that I think if you're interested in the community might be of interest to you. The Zowe Explorer is one of the more successful components as measured by downloads of this technology. Those of you that may not be familiar with this is an extension to VS Code that opens up VS Code to accessing and working with ZOS, you know, I'll just say resources in general. So building a conformance criteria around that is something so that other people can write extensions on top of the Zowe infrastructure. So that's one that's important. The Zowe CLI, we'll let Mike talk about that. The one he'll highlight is the profile management that they're working on. Rose, if you go to the next slide. The mediation layer, right? This is kind of the traffic cop for REST API management as well as access to ZOS resources through Zowe. So you can see there, I want to point out that there is work going on a high availability configuration for not just the mediation layer, but also the Zowe components that make use of the mediation layer. Also, the Zowe application framework, or what we sometimes refer to as the Zowe desktop, we're working on containerizing that to have Docker images in the future that allow you more portability in where you may run this infrastructure. And Rose, if you go to the next slide, I mentioned the system team. They're heavily involved in designing the high availability aspects of Zowe. And then the onboarding squad having to do with improving our conformance program process, and just, you know, how do we recognize those vendors and products that make use of the new capabilities that we deliver in Zowe. And Rose, next slide. Documentation, as I said, we recognize that there are a lot of different consumers of Zowe. So figuring out a way to give you an entry point, whether it's in the documentation or on the website, so that you can find the information that you're interested in based upon whether you're a consumer, a developer, you know, or a user of this technology is key. And then Rose, next slide. Just some quick advertisements here. You might have skipped a slide. The Open Mainframe project recently ran a summit. Zowe had content in that summit, and those sessions are available on YouTube if you want drill down information on some of the Zowe components. If you go to the next slide, Rose. And then we also did a 3-hour session for Share, also with a deeper dive in the technology and what we're working on. We had great attendance. We hope to use Share in the future along with these quarterly updates and work with the OMP on topics. So Rose, I think that's it for my section. So what I'm going to turn it over to now is Joe Devlin. He's an expert in what we refer to as ZSS, one of the components of Zowe, and he's got some great ideas on how to expand the capabilities today. And for those of you that have a C development background and want to make use of ZSS, Joe's got some great ideas. So take it away, Joe, and I'll keep an eye out on the Q&A channel for questions as you go.
Okay, just Bruce, to confirm, you can see my screen and hear my voice.
Correct.
Okay, that's key. Bruce said I had some great ideas. I think that in the spirit of open source, which is where the OMP is part of the Linux Foundation, we'll find out whether any of my ideas are great through adoption or not, which has always sort of been that gold standard in the open source. So that if at the end of my short time here, this has no influence or everyone thinks I'm dead wrong, then it wasn't a great idea. But I hope that it is, and I know that some of these ideas have been used in Zowe, at least for supporting the back end of how the Zowe UI works. So a little bit about me. I've been programming, I'm gonna say most of my life for 40 years, and about half of it on mainframe and about half of it not. And so I sort of have a perspective of what does the mainframe feel like to a person who is not fundamentally a mainframer. And in particular, I sometimes say mainframe when I mean ZOS, the historical MVS, the proprietary operating system of the mainframe. So just to get to my disclaimers here, let me get on the screen. I'm having trouble advancing my slides. Oh, that's better. We're always talking about Linux. So when never talking about Linux on Z, only talking about ZOS. Sometimes I say mainframe as shorthand. I don't want anyone to be confused. Again, IBM Linux on Z is a wonderful Linux and does all the great things that Linuxes do. And I apologize if there's ever been any confusion caused in that area. So, so ZOS will be a major enterprise platform for at least the next 1 or 2 decades. I mean, people can prognosticate, but I know that the value of the applications and the size of the data is going up every year, and it seems to me that the number of people, I was a CTO of Rocket Software for a few years and have been an executive in this area. I know well that people are not leaving this platform. Maybe not that many people are getting new onto ZOS, but the attrition rate is extremely low and the value of the business is extremely valuable. So, yet the business problem is that we're running out of programmers who can do the deeper stuff, and it's, yes, to some extent, there are a lot of programs that already exist and we're building APIs to them. But, suppose you want to build a better mousetrap, or you want to take advantage of new Z hardware, like they do a lot more with security. There's new, opportunities for more parallelism in processing. There's SIMD instructions. There's probably, in the future, there's always rumors of better AI engines and other things. And even taking advantage of 64-bit code, there are a lot of mainframe applications that have stabilized as 31-bit applications, and it takes code. You just don't recompile and get 64-bit on the mainframe. You have to change the APIs you use for getting memory and the like in many situations. So, you know, I have found in the process of bringing people onto the mainframe, onto ZOS, that, you know, it takes a long time to be good at this, and to be, you know, 5 years to be good, to be valuable to yourself for writing backend code. I'm not saying for consuming a web service or a CLI. That stuff you can do relatively quickly, sometimes in weeks. But, you know, to be a backend developer and then to be a resource, to be a leader for other backend developers, it takes a real long time. And, you know, just many people are leaving the field as things go. And then also sometimes you might want to rewrite things because, or improve things because there are, you know, it's a known problem that the interface of many things on ZOS is somewhat behind the times of other areas. So the particular focus that I have in the talk today is to build privileged applications, not applications that deal with user data. We're not talking about bank account or stock portfolio management or any of the other things that people typically do, and that's the work that people do in COBOL, and primarily, or nowadays in Java, in a WebSphere or something. That's all very nice and very valuable, but we're really talking about the side of your programming that either customizes the system or builds fundamental monitoring products, the main views and Omegamon, sysviews, and all the other stuff that we're familiar with, security tools, profilers, when you want to go and extend the mainframe. I've worked on a cloud storage product back when I was at Rocket. There's a lot of stuff that requires you to face the OS, and it is a sub-practice within mainframe programming that is very, very different from the experience. It's like COBOL programmers and back-end programmers, have very, very little overlap in what they know and what their experience of ZOS is. So one of the things that happens when people come on, I like to hire people who are, good C programmers and an interest in languages and operating systems come on, but ZOS is still astonishingly different than Linux. I don't know if everyone knows the animal there, but that is a platypus, which seems to have a variety of features of the entire evolutionary history of mammals and reptiles in it. And, it's the ZOS is, and the Z hardware is full of the best ideas, the virtual tasking, virtual memory, multitasking, hypervising, all this stuff came from innovations that were on the mainframe. And, even the notion of software architecture or ABIs came from OS 360, the original OS. It's full of good ideas, but because of the commitment to backward compatibility, every good and bad idea that is on ZOS, save a few that were expunged, is still there. So as they move from a 24 to 31 to 64-bit OS, there's full APIs at all stages of this evolution, and you have to contend with it. It's not transparent. When I think it was kernel 2.6 in Linux, they moved to 64-bit, recompiled everything, so the transition from 32-bit to 64 Linux happened relatively overnight. That overnight for ZOS is still going on between the year 2000 and now, where it's still somewhere in the middle of that journey, until every pointer in every data structure allows 8 bytes. We're not done. And there's, if people who know the operating system on the call know that probably more of the pointers are 4-byte pointers than 8-byte pointers at this point, and it's quite a journey. So, and the mainframe, the ZOS has made various attempts to be Unix-like, but the USS system is confounding to people who come on to ZOS. They don't find the things that they expect. Again, I hope there are some people out there who are more Linux C programmers and, can see from some of this perspective, or have seen some of this perspective. So when you're writing privileged code, you know that if you've written a driver or a kernel extension, or even just looked around inside the Linux kernel sources, you know, you're really building something that's an OS extension, and it has to be perfect. You know, you just can't leak info, you can't allow privilege, you know, escalation and all these things. You have to clean up because you're just not going to shut down that process and get the process teardown to fix up everything you do. You have to deal with multiple versions. You know, writing privileged code is, you know, much more strenuous than writing a one-off, you know, user application or a single end-to-end batch job that just runs and shuts itself down. So, you know, it is just really here, I'll not go through all these points individually, but this is part of the learning journey that people have to go through. And the experience in ZOS is never really exactly the same. You have to slowly acquire, coming from your, you know, usually your university education nowadays, and being familiar with all the terms in the left column, and then you get to ZOS and you slowly learn, you know, what these things are. And one of the interesting things I'll point out here is there are many things that don't even have an equivalent. Like the mainframe, the mainframe hardware itself has a different storage protection system than x86. They have something called keys rather than rings, and you know, modern x86 operating systems only use protected and user, you know, rings. ZOS programs and do use all 8 or even all 16 keys, and talk about the other keys. And then there are other things like the fact that you can talk to multiple address spaces simultaneously. That's the lowest one here, in a single program. That is just a really, really foreign concept to people who come in from the world of Unix or Linux. You are in a single address space. Your addresses only get translated to physical addresses in one way at a time. You know, learning things like AR mode and ALETs and address space control modes. You know, learning that the mode of your processor can be using 24, 31, or 64-bit mode. You know, that is a lot to get over. That's what slows people down, in that they get onto, you know, one of the things that slows people down, they get onto this platform and they have some really deep learning to do about those differences.
Hey, Joe,
so
you're about halfway through your time. If you,
I gotta go, so I can speed it up. Boy, oh boy.
Okay.
Yeah. So, so when you get into Linux kernel programming or privileged program, there's a path to follow. There's a lot of you know, examples to base your learning on, and I'll skip through that. But the privileged programming on the mainframe, or ZOS, excuse me, is you know, is a bit more challenging. There's not a lot of canon out there. There's an OMP project right now to bring in something called the CBT tape, which has many examples of system level programming, but usually in assembly language, onto you know, into the fold of the OMP. I hope that goes well. But in general, there's, you know, not a one true path for building privileged programs, and most of the traditional products, aside from batch code, or, you know, anything that's a server that provides services to other programs, is usually some very, very non-standard thing that you know, is believed to be secure, but there's a lot of patterns in mainframe code of writing code that uses key 0, building the interface from user to kernel mode, or what is called supervisor calls and PC calls on ZOS. There's a lot of gotchas to that, and companies like RSM Partners, I think they're part of BMC now, you know, they, yeah, and there are other products too, I just mentioned them because I know them, but that, you know, there are vulnerabilities in these assumptions, and a lot of these products were developed when networks, you know, and cracking were not as mature as they are now. And so building a new mainframe product that is privileged from scratch is a really daunting task because you have to get everything right. And again, ZOS programs tend to be the programs that hold the most valuable data and are the most interesting for, you know, corporate or foreign espionage to want to get at. But, you know, there are so many things to learn about Z program where, you know, that's the typical look of the programmers that I've hired over the years to become masters of this, just like, you know, just to go and handle errors. There are so many ways of, in the resource management, there's so many things you have to master to build a robust program. There are so many different kinds of APIs for doing certain kinds of tasks. You don't just have normal code in a normal process or address space. Sometimes you have to do things through interrupt requests, SRBs, you know, other things that you just, it is the total number of situations that you have to learn to be a master, and ZOS are much higher. So the framework that I developed and continue to work on after leaving Rocket is ZIS and ZIS. And, you know, the thesis is that you need a framework, especially if you're developing from scratch. And the ZIS, let me go forward to a slide that talks about what this framework is more visually. When people write a server on the mainframe, a new one, they might write a C program or a Java program. And, you know, when we were developing the Zowe UI, we built an HTTP server and made various native calls, but it wasn't really robust because we had to have privilege in that ZSS process. So it got a second level of design, I think before the first release, I hope so, where there is a ZIS in the middle, the red box. This is where it is effectively a, I don't want to say container, but a framework, an application that can hold plugins in it that can do various privileged services in a way that you know how to build that small snippet of code that does something that requires privilege and can properly secure it. And it's amazing how short this can be. I'll go very, very quickly into an example of this. If you can see all of this out on GitHub, this is not, you know, 99.9% of this is all pushed up to a GitHub. And this slide deck went out to everyone, I assume, Rose, so they can pick this stuff up. I don't need to hop in here.
We'll make sure it does.
Yeah, okay. And let me go over to something in the code. So,
Joe, you got about 10 minutes.
Yeah, okay. So in ZOS, you have this wonderful feature that came out after 64-bit mode came out called 64-bit memory objects. Of course, you need new programming to exploit them, exploit this feature. That tends to be because of the backward compatibility rule in ZOS, that to use something, you have to opt in. You don't ever automatically opt into something, or rarely do. And so that you had to go and explicitly take advantage of these services to be able to build, an application that wants to use 64-bit addressing. And yet these interfaces are often privileged in some way. So it's sort of like, not only do you want to use this, but then you would need to get permission to secure your program, and that while you're a developer, you can go and APF authorize. APF authorize is sort of the equivalent of declaring that you have, root permission, that you can effectively, once you're root in Linux, you can self-escalate to anything else. But you don't get this in the real world in deployment. Responsible mainframe system managers, they very, very careful scrutiny of every program that they bring in that requires privilege. And so how do you go and take advantage of a service like that? So inside the ZSS libraries, there's one of the things that's already been there for a long time is shared memory services. And it's a nice set of facilities to be able to make not only 64-bit memory objects, but to be able to share them, either share them with all other address spaces on the system, or share them in a one-to-one or friend relationship, that you share these memory objects with other programs explicitly, yet you need privilege to do that. You need to be, I think, running in key 0 or 0 through 7, meaning you need to run in a system privilege key to do it. So to build a ZIS plugin that does that, I just made a very small one last night because it really isn't very hard to do this. When you want to build a ZIS plugin, you just need to make a simple descriptor object that goes and says, what's the name of my ZIS plugin, and what APIs, the APIs get 16-letter names, I will have in them, and what function in my C program will handle them. There are templates and examples out there for doing this. This is just derived from the build script of another test plugin that was in the distribution, but all I'm really doing here is adding my one little file, ZIS main, to this. And the feature that I'm building is create shared memory, which is just passing the call over to the existing library inside the ZSS. And so one of the things that's interesting about this is that the thing that you have in Linux, or a lot of other operating systems, called a syscall, which is sysenter in the x86 implementation, is the ability to have a privilege escalating call, that a user program calls a certain program, maybe to do I/O or allocate memory or whatever, and the standard interface between your user mode program and the kernel is something that's a call gate or boundary crossing, something that escalates privilege from user to kernel mode. And this framework here, the simple way that ZIS works, is that you declare a function and you're making it be a really secure service. You have the way of making the memory transition, of copying the data from user space into your privilege space. You do your work. All the real work is doing here is either allocating a shared or common block, and if the shared block, additionally permitting access to the target program, copying your results back, and off you go. This is it. And so all this hard stuff that you would spend years learning to do this properly and securely, and it's pretty much being done for you. You can now, by policy rather than mechanism, choose any secure service that ZOS can do and bring it into a convenient, manageable interface. and manageable, I mean that you can bring it in, and this is the improper way of doing it, don't give it any security. That's not a good idea because this is a privileged service from the operating system's point of view. So something I brought in, and I hope will commit to ZSS very soon, I hope the team of pull request reviewers will accept it, is the ability to assign a specific privilege class, a facility class profile. That's sort of the mainframe equivalent of LDAP, is the ability to say that this resource name can have this privilege for this user or this group of users. So I can go in my demo here and call the properly authorized version of the service. Let's go in here and do it.
Hey,
and now I'm
Joe,
going to attempt to call to make.
Joe, you got about
2 minutes here.
Okay, all right,
Yeah,
and we wanted to get to the poll questions too, so.
Yeah, okay, we'll get in there. So
okay.
I just called this service and I got slapped down by the operating system because I did not have privilege. I knew that with the, or I got slapped down by this server because I didn't have privilege to do it. Then I can go back into, this is a system manager's account logged into 3270. I can go and to command the tell. RACF is the security manager being used on this particular mainframe, and rerun that command. And now it works. So now I've gone and taken a really important, valuable service in the mainframe, put a little interface on it, and now properly secured it. And so what I'm going to do further from this is to go to the what's next slide. So, I'm working on some additional features in ZSS. I'm making the non-privileged part 64-bit ready. The privileged container, ZIS, was already 64-bit. I'm building in extensions to support generating your own SRBs and IRBs. I don't have time to explain what those are today. And I'm working on a project that makes use of this, which is an open source debugger, system inspector, and dump analyzer that maybe I'll give another talk on, something called Project Inspect, which is, my hobby horse. And, hopefully by building an open source project that makes use of these ZSS and ZIS capabilities, we'll provide more examples to the community of how to do things that are considered really wizardly relative to ZOS programming, but accessible to people maybe within their first year of programming rather than, after 5 or 10 years of suffering. I want to make a particular shout out to something that you should look at, and it is mentioned in the deck. That's something I clicked on in passing here. There's a secure engineering mini course that Rob Scott has presented at a number of different share and GSE sessions, and there's a link to it in the slide deck, and everyone should go through this and to get the full awesomeness of the responsibility and the intricacy of writing code that will not compromise ZOS security and allow you to present the proper controls to the system managers that use your code, and how to pass security reviews and audits that you will get more and more, and build products that will pass with flying colors when RSM and other pieces of software are run against your product, that you want to have something that is future oriented. And that's a lot of what we're doing here at ZSS and ZIS, is being security ready. And again, I could go and get Rob come as a guest or present this some other time if people are interested in secure engineering.
Hey Joe, I think
anyway,
time's up. Rose, did you want to do a couple quick survey questions, and we'll turn it over to Mike?
I do. Mike, while you're getting ready, I'm going to launch a couple questions. First one, let's see what. This one should be launched now.
We do see it.
Okay, cool. Just take a few seconds to. That one.
And Joe, we didn't have any Q&A, at least in the chat window, but those of you that may have a follow-up question for Joe, you'll notice on the slides he does have his email address, and definitely reach out to Joe, and if need be, we can figure out a deeper dive so that Joe could cover this in more detail for those of you that are interested in what he's proposing.
Okay, next question's up. Take a look at that one. Do you plan on developing new back-end code for ZOS? Okay, next question, real quick. Do you have problems getting back-end developers, scene assembler, hired and trained? Yes or no? Are you continuing to train back-end developers in assembler primarily? And just one more, so Mike Bauer, get ready to share.
Yep, I'm all ready, Rose, and whenever we finish up the polls.
Okay. Finally, do you use XLC Metal C? Yes or no?
So while that's wrapping up, thanks so much, Joe, for covering this. And we'll see what your response is like. It definitely, based upon poll, there's some interested parties out there for what you're building.
Yeah, I hope so. Thank you.
Okay. Take it away, Mike.
Okay, thanks, Rose. Thanks, Bruce, and thanks, Joe, for the excellent presentation. I want to talk a little bit about our squad focus for the Zowe CLI squad coming up in the current PI. A couple of our initiatives we've led in the past. We led the incubation of the Zowe Explorer, which has now grown into its own squad. And we also recently incubated the Zowe SDKs, Zowe Client SDKs. So if you're not aware of that initiative and interested in programmatically interacting with ZOS using Python, Swift, or Node, feel free to contact me. But in this upcoming PI, the CLI squad has shifted its focus back to the CLI. And one improvement we're looking to help with is team enablement. So we've seen a lot of folks out in the community getting started with the Zowe CLI, but we want to help them get their team involved and see the use of the CLI on different projects. So the Zowe CLI squad in this PI is working on features to enable team usage. And I'd like you all to take the opportunity on this call to provide any feedback on our proposed direction or any challenges you're experiencing in your use of the Zowe CLI. So before I start talking about the improvements for the current PI, I want to take a moment to talk about profile basics where we started, what we've done to improve the experience, and then I'll discuss where we're headed. So what are profiles in the terms of the Zowe command line interface? Profiles allow you to store default command options so that you do not need to specify them on each command. And a lot of different client software in Zowe make use of these profiles. So profiles, for example, they're shared between the CLI, SDKs, and the Zowe Explorer. So you create a profile and you can use it in any one of the client technologies. Here's a sample command without profiles. So you see I want to list data sets. I provide a custom pattern, and then I have to specify information to connect to, in this case, ZOSMF. So I have to specify a host, a port, whether or not I want to accept self-signed certificates on the server. That's what the reject unauthorized flag is, as well as provide a username and a password. So this can become arduous if you're running the CLI interactively. If you store that information rather in a profile, your same command becomes much more simple. Just Zowe files list data sets and you provide the pattern. Another aspect of profiles is that you can easily switch your default profiles to easily target different systems, and you won't have to change your scripts. So if you provided all this custom information in a script and then all of a sudden you move your development or your project to another LPAR, or you access different services, you would have to change your scripting logic to some degree. If you make use of these profiles, you can just easily switch between really where you're running your automation. Now, profile management. I feel that profiles are fairly easy to manage today as long as the number of services you are interacting with is small and you are not frequently targeting different services of the same type. So for example, today, if you're using, you're developing on for one project on one LPAR and another on a different one and so on, and you're using different services, it's very difficult to direct your client to the appropriate set of services. But if you're only interacting with one ZOSMF and, for example, maybe one Endeavor instance, then it's a fairly small set of services to manage, and I would suspect you're probably not facing much of a problem today. However, we've seen that the Zowe ecosystem has continued to grow. Regarding CLI conformance, we're up to, I believe, 25 conformant CLI extensions, and they all, or most of them, add another profile because they're connecting to another service. So this influenced us to introduce the concept of base profiles. And there are a lot of benefits of base profiles. One key aspect of them is they enable a single sign-on experience when using the API mediation layer. I don't want to go into the details of single sign-on here. If you're interested in those, feel free to contact me offline. I want to talk about the benefits of base profile even when just accessing services directly, okay? So base profiles contain information that is applicable to all profile types. So these properties include things like hostname, port, username, password, and reject unauthorized. You can now think of the profile types we had previously: ZOSMF, Endeavor, FileMaster Plus, Kix, DB2, the list goes on. Consider those as service profiles. Those service profiles will continue to take precedence over what's in your base profile. But this created a problem, right? Because if I'm accessing, 15 services, and then I need to provide my username and password in my profile. So even though it's stored securely, something like that, I still have to manage that in 15 places. The addition of a base profile allows me to manage that username and password combination in one place. Also, if you ran all these services on one host and then had to switch, you could also keep that information in your base profile as well. Just makes the effort to update, especially username and password as they may change frequently, makes the effort to update those very small, and the number of places they're stored very small. So here's an example leveraging base profiles. So this is sample creation commands for profiles. The first is creating a ZOSMF profile, and the second is creating an Endeavor profile. So again, I have to specify all that information in both profiles. But below, I show that I could specify most of that information just as part of the base profile, and then specify only the different information in each one of my service profiles. It makes managing this information a lot more easy because when you have to update things like username and password as a key candidate, I then only have to update one profile rather than 10, 20, 30 profiles, depending on how many services you may be interacting with. So what are the profile challenges that still face us today? Well, today, profiles are user-based. So each user needs to set up their own profiles on their client. If they have multiple clients, they're going to have to set it up on each one. And if you are targeting different systems when working on different projects, you need to remember which profiles to set as your default. I remember the other day I was working on a COBOL CICS application, and I leveraged, for example, the FileMaster Plus plugin to perform a copy basically, I was trying to deploy my application to a test environment. And I found out I was copying on the wrong LPAR because I hadn't repositioned my client to talk to the LPAR for that project. So that's one difficulty. And then profiles are stored in multiple folders, which kind of makes them difficult to share, especially when you're storing username and password in multiple files. If you're not taking advantage of base profiles, that can become difficult. And there's been workarounds we've seen in the field. I proposed one as well as part of this blog I listed, in that you could automate profile creation. And that's what I'm currently doing for my projects, so that when I pull a project down from GitHub, I just have to run a script that'll orient my client to the services I need to interact with when working on that project. The problem with this is somebody has to set up that custom automation, and then every time a team member wants to use it after they pull it from GitHub, they have to run the automation to reorient their client to the appropriate services. So the direction we're going in this PI is towards what I call project profiles. So we want to represent, first we want to represent all profile information in a single document, and that single document would be more easy to share, and it could be maintained. It could be checked into source control and maintained just as part of the project. And then when a team member checks out a project that has a specially named file, I'm proposing zowe.config.json, their client will respect those settings when working on that project. However, different users may have user preferences or things they don't want to store in source control, like credentials. And there will be another file. I propose the name to be zowe.user.json. It may change. It could be added alongside that zowe.config.json for user-specific options. Again, you might not want to share some things with the team, and you may not want to check some things into source control. And just to state, I don't know if everyone's familiar with the command line order of precedence, but when you run a command, the first place we look for an option is, did the user specify it on the command line? And if the answer is no, we look for environment variables. Environment variables have a special naming scheme, Zowe_opt_, and whatever the name of the option is. If it's there, we take it. If it's not there, we will look in that zowe.user.json for user-specific settings for a project. Not there, we'll look in zowe.config.json settings, which are shared amongst the team for a project. And if it's not there, we'll look in user profiles, which is what's available today. And also, I talked about service profiles and base profiles. A note in each level, 3, 4, and 5. Service profile information would override base profile information. I don't have too much time for a full demonstration, but I do want to show a couple key aspects because me personally, I'm a visual learner. So being able to see the current structure is a little bit easier than listening to somebody talk about it. So here I'm in my home directory under my .zoe folder in my file system. And how profiles are managed today is there's just a profiles directory. And in each profile directory, you have all your profile types, base, for example, I see view, Kix, DB2. I have a lot of plugins installed. And then within each profile type, you have your profile, the name of your profiles in a YAML file. And they contain information like host, port, username, password, etc. Things you don't want to specify every time. This becomes a little bit difficult to maintain. Again, one way of solving the maintenance problem is to run things like npm run init, where I might have some custom automation that will go off and set up all my profiles for me when I'm working on this project, and then I can switch projects. That's where we are today, and that's what's possible today. But where we want to go again is, instead of having all of that file structure, just have a single document, zoe.config.json, with the user profile settings. Open this really quick in Visual Studio Code. So you can see this is just, the CLI doesn't yet respect this. This is just, I wanted to put this together to show you visually what you might have. These are user profiles, and they're just represented in a single file. So you still have types of profiles and names of profiles, but it's all in a single document, which is a little bit easier to share and check into source control. Now that's user perspective. Now also within a given project, so over here on the left, we see I'm in project 1, you would have a zoe.config.json live there as well. And you could store information for this project. So when I switch to this project, for example, I'd be working on this marbles application. But maybe in project 2, if I went to that project, I'd be working on this slick oil application, right? And you'll notice that there's some information not specified in here, like username and password, and perhaps that could be stored in a user override setting. Again, this information would be managed by the secure credential store. So where we're at today, profiles managed in a file system. Where we're heading, single profile for user, and then also project-based profiles that would have precedence over user profiles. So you can easily check out a project and immediately start working. Nothing to do. So, and it's also nice for sharing this among team members, because only one person needs to really set it up initially, and everyone else will get it for free. That's all I have as far as our direction. If we would now like to open it up to polls, Rose, feel free.
You got it. Okay, I'm going to relaunch. Go into the first poll. How would you describe your use of Zowe CLI? Check all that apply. It's multiple choice. Still coming through on that one. And we'll have one more question and we'll wrap up. Okay. And then, how many Zowe CLI profiles do you manage today? In general, the number of profiles is equal to the number of services. So your best estimate. Whoops, that didn't launch. Here we go. You should be seeing it now.
Yeah, so another way of asking this question is just how many different services do you plan to access with the Zowe CLI within your organization? And if you were accessing, for example, 2 different instances of ZOSMF, that would count as 2 in this case.
Okay. All right, while I'm taking the screen back, Mike, there is a question in the Q&A.
Okay,
do you want to take
reading
a look at
now.
that one?
So the question from Sean, thanks for the question, Sean, is with upcoming high availability initiatives for Zowe servers, what can users expect for how this impacts the CLI? Will it just work, or will there be changes to profiles or prereqs of server configuration? Things to be aware of for differences between LPARs. That's a good question, and certainly something we probably need research on to confirm. But I'm hoping that with the high availability configuration of the API mediation layer, that would be handled within that that level of technology, but I'm looking for the API ML squad to advise if we would need any changes specifically with the CLI. I hope that answers that question. It's I know the API ML squad, that is one of their focus areas in the current PI. So that's typically how a lot of these things emerge, is that you look for the CLI to somewhat follow the capabilities and enhancements offered by the API mediation layer. Certainly how single sign-on was rolled out.
All right, thanks, Mike. All clear on the Q&A?
Yep, I see no more questions.
Okay, and you're seeing the presentation again? Confirm?
Yes, I am.
Yes, we are.
Okay, super. Okay, just a couple quick slides, folks, before we wrap this up. We want you to be aware of a couple dates. We've held one Zowe system demo in this current PI that we're in. We have 3 more scheduled for this PI at approximately these dates. The next Zowe PI planning is tentatively scheduled for January 7th through 8th. Of course, these dates are subject to change. Those dates have not been finalized yet. We have the share replay that Bruce mentioned earlier. We'll send that link out with the recording. And typically there are Zowe topics presented at the various, from the various contributors at DevOps.com, so certainly check that out. Let's see, also the best way to stay in step with the Zowe Squad meetings, the Zowe system demos and PI planning, is to please either bookmark or add the Zowe calendar to your own personal calendar view. Those links are provided here, and again, we'll send them out with the recording. Finally, if you're looking to engage with us, we are all hanging out on Slack, openmainframeproject.slack.com. Popular channels are listed here. For example, you'll find Mike Bauer on Zowe CLI, Zowe User, probably Zowe Explorer, and the general channel, and you'll find me on the Zowe onboarding channel. And then finally, make sure you mark your calendars for our next webinar scheduled for Wednesday, January 20th, same time, 11:30 Eastern. When in doubt, go to the Open Mainframe Project events area, and we have it circled here. You should have the upcoming webinar located there. Registration is open for that webinar in January, so please feel free to go ahead and register for that. We look forward to seeing you. And I think that does it. So thank you so much for joining us. We hope you found it informative. Special thanks to Joe Devlin and Mike Bauer for our focus presentations. We wish you all a great quarter and be well.
Thank you so much, everybody. Thank you to all our presenters. And this will be up on YouTube tomorrow. I will send an email out with the polling questions to everybody. So look forward to that. Have a great day, everybody.